On Tuesday, we started the notes on Z-scores. And so we talked about the standard normal distribution. So instead of just normal distribution, when we work with the standard normal distribution, this is the one where we have mu 1, 2, 3, -1, -2, -3. Where with our normal distribution, we had mu, and then we'd have mu plus 1 theta over here, or sigma, sorry, plus 2 sigma, 3 sigma. So remember that when we work with standard normal distribution, we're going to be working with Z-scores and those Z tables that we looked at. And in that case, we want this bell curve. So mu 1, 2, 3, because remember that our Z-scores are always within those numbers. So we worked on a positive Z-score and a negative Z-score. So positive Z-score means the data value is above the mean, while negative is below. And we worked on calculating the Z-score, which is just this equation here, okay, where x is your data value, mu is your mean, and sigma is your standard deviation, just like before. And most of the time you'll be given mean and standard deviation, and remember that if you are given mean and standard deviation, do not calculate them yourselves because you're given them. And we talked about the area under the Z-curve, and that's where we used our data tables. Okay, because your Z-score will give you a number between 0 and 3, and it can be positive or negative. If you get a negative, that's fine. Just go and look at your negative score. And then remember that we broke our Z-score into 2 parts. So if we, in the example, we had 1.27. So it's always the first 2 digits, so the digits on either side of the decimal, and then the last one. So this will break down to 1.2 plus 0.07. And then these will be in the rows, and these are in the column, and you go down and you find where they meet. And where they meet gives you a fraction of the data, and then you times that by 100 to get a percentage. And remember that if we go back to our curve, where in the normal distribution, 100% of the data was underneath the curve. When we talk about standard normal distribution, it's an area of 1 underneath the curve. Okay, so when we talk about that 1, when we get 0.898, like we did in our example, we times that by 100 and we get a percentage. So we did those ones. Okay, so let's start on this one. A company that makes bungee cords has to follow strict quality control procedures, of course, because we don't want a bungee cord to break on us. A bungee cord that is shorter than 42 centimeters must be rejected and cannot be sold. The mean bungee cord length is 45.2 centimeters with a standard deviation of 1.3 centimeters. So this tells us that our mean is 45.2 centimeters. And our standard deviation is 1.3 centimeters. And so since we have mean and standard deviation, do not calculate them. You don't have enough information to calculate them, so just use the values you're given. So what percentage of bungee cords are rejected? And so what we want to do is, first we'll find our Z-score. So remember that Z is x minus mu over theta. Our x will be what qualifies a bungee cord to be rejected. And you'll see up here it tells us anything that's shorter than 42 centimeters. Okay, so we'll go 42 centimeters minus our mean is 45.2 divided by 1.3 gives us a Z-score of -2.46. And remember that a negative is an okay answer. Now we're going to draw our standard normal distribution. So it's still a bell curve like it was before. Our mu is still in the middle, and then we have our 1, it should be a 1, 2, 3, and our -1, -2, -3. Okay, and so we're going to look for -2.46, which will be somewhere around here. So it's everything less than this. And since it's negative, we know we go below the mean. So defines the percent of bungee cords that are rejected. This is where we have to use our z-score, and we have to find on the table. So we break this down, and it will be z equals negative 2.4 plus 0.06. And grab out your z-score tables. Okay, and then what you'll find is that on the table, negative 2.4 in the column and negative, or sorry, 0.00 or 0.06 in the row, they meet at 0.0069. So we take this and we multiply it by 100 because we want a percentage, and we know that because the question asks for what percent of the bungee cords are available, are rejected. And if we look here from our z-score, from our standard normal distribution, it should be quite a small amount. Okay, it's just that very, very end part over there. And when we multiply this by 100, we end up with 0.69% of cords are rejected. And we can square that up, and that's our answer there. So then if we want to look what percentage of bungee cords are kept in order to sell. So basically, everything that's not rejected is kept to sell. And so all we have to do is take 100 minus 0.69, and that gives us 99.31% of cords are kept to sell. Okay, and if you went back to look at what that would be, it would be all of this stuff. So all these cords are kept to sell. And so it is quite a lot. It's most of the cords are kept to sell. So we did talk about these questions on Tuesday, but if you didn't finish them, you can go back and finish those, and those will be talking about z-scores. And so again, use your z table. You'll have one in class for the test, but you can use the one in the back of your textbook. You can print off the data booklet if you want, or you can just Google it. I'm sure there's one on Google. Now we want to look at, if we have two z-scores, we want to know what the area between them is. Okay, so maybe everyone who falls between, one test score and another test score, or something like that. So if we look at our two z-scores, z is 0.25 and z is 1.57. And again, if we label our mu 1, 2, 3, -1, -2, -3. So we have 0.25, I'll just put that there, 0.25, and 1.57, and I'll put that there, 1.57. And so what you want to do is find in there. Okay, so what is in there? So basically what we can do, since we can only find the data to the left or to the right of each z-score, we'll find the data to the left of each and then find the difference between them. So let's go through that and you'll see what I mean. So if we have z equals 0.25, we have z equals 0.2 plus 0.05. And on the table, this equals 0.5987. And we multiply that by 100, and we get a percentage of 59.87%. And we'll keep both decimals until we have our final answer. When you have your final answer, you can round up. But until you get to your final answer, just keep all your decimals. And then same thing here. We have a z of 1.5 plus 0.07. On the table, this equals 0.9418. And feel free to pause the video and go find these on the table so that you're comfortable using the table and that you're using it correctly. We multiply this by 100, and we get 94.18%. Okay, so if we go back on here, we can label this. So here is 59.87%, because that's the 0.25. And then the other one, if we take it here, it is 94.18%. Okay, so what we want to do is find this area here, the difference between the 94.18 and the 59.87, and that will give us the area in between the two. So the area in between the z-scores is the difference. So we're going to subtract the difference in areas. Okay, so the percent of data in between equals 94.18 minus 59.87 equals 34.31%. Okay, and remember here I put percent. Always give your answers a unit. Okay. Now we can determine the z-score for a given percentage of data. So this is working backwards. So if I give you a percentage of data, you can go to your z-tables and work it out to find your z-score. So we can work backwards. So if we look for the percent data in the center of the table, so what z-score is required if 10% of the data is left of the z-score? And so what we do is we turn this 10% back into a decimal, because the z-score table uses decimals. Remember that we're always multiplying by 100 to get our percentage. So if we just divide 10 by 100, we get 0.10. Okay, and then we have to look for that in the z. Now we look for the closest we can get to this. So look for the closest value. And remember that we're going to be in the middle of the Z table. So when you have your Z table like this, you have that Z, and then you have all those values there and all these values here. But you're going to be looking in here. Okay, so you look for the closest to 0.10. And the closest value, and again, feel free to pause this and look for it, okay, because it's important that you can use this Z table. So the closest value is 0.1003. And this is a z-score of negative 1.28. And remember, so if you find 0.011 or 0.1003 on your z-score, first go out to the left and you'll find that that's negative 1.2, and then go up to the top and that's 0.08. Okay, so that's your z-score. Okay. Now if we go down here, what z-score is required if 25% of the data is to the left of the z-score? So again, we want to get into a decimal, so we do 25 divided by 100, and we get 0.25. And look for this, so find the closest value. Okay, so if you look in your z-score, there's 2. So you can find a z of, you find 0.2483 and 0.2514. Okay, and one is not really closer to the other. So we find the z-score for both. So in this one, our z is negative 0.68. And over here, our z-score is negative 0.67. And again, please take the time to pause the video and go find these for yourself. So since it's between these two values, what do you think we need to do? think back to what we've been finding the whole time. We're going to find the average. So since 0.25 is between these values, we'll take an average. So our Z equals negative 0.68 plus negative 0.67, and this is all divided by 2, and that gives us a Z-score of negative 0.675. And then the last example, what Z-score is required if 15% of the data is to the left or to the right of the Z-score? Okay, so now be very careful, because remember that our Z table gives us the values to the left. So I'm going to just quickly draw one of my standard normal distributions here. That's a pretty terrible version, but that's okay. There's my mu, and my Z-score, I want to find, I'm just going to basically draw just a quick one, everything over here. So this 15% of the data. But my Z-score is given in terms of this area here. So how do I find this area? What I have to do is the percent of data to the left is going to be 100 minus 15, right? If to the right is 15, then to the left is 100 minus that, because 100% of the data has to be underneath. And we get 85%. So then 85% is to the left. So then we can find that on the Z table. We do 85 divided by 100, and we get 0.85. Find the closest value in the table. I don't know why I put F there. Closest value in table. We find that it is 0.8508. And this translates to a Z-score of 1.04. So this 1.04 represents the value, or the Z-score to get 85% of the data on the left side, which necessarily leaves 15% on the right side. So in the textbook, you can work on these questions. I'm going to post a short video on things that you should know for the test. I'm also going to be posting the bonus quiz. So it will go up today, probably this afternoon sometime, and then it will be taken down on Saturday morning. So make sure you get it. Again, not very many of you are doing the bonus quiz, but it's such a good idea because it's just extra marks. Even if you don't get full marks, it's something, right? It's also a really good review. Make sure you are working on the review. There's no worksheet for this section of the chapter. Just make sure that you do the textbook questions for practice. Also make sure that you've handed in worksheet 5.3 and 5.4. And if you haven't, bring them in on Tuesday. You can come see me today, although it'll be too late for you guys to get this, today for help after 9:30, or come see me Monday afternoon after 2:30 if you need any help before the test. And so the test will be first thing in class on Tuesday, and make sure you bring rulers for the next unit. All right, have a great weekend, guys.